I have no idea how this is going to pan out. Okay, that's well done. The host, hold on, it says speaking on the state of education and essentially my philosophy on well, I should have said on teaching, but what am I gonna do, man? What am I gonna do? Anyway, ladies and gentlemen, since we all know pi, let's make this art. Now again, as you might have noticed on Bossman Digital Media, well, you see, Bossman Digital Media is more red and black, and I am in the black and black. So anyhow, what we're doing? No, there was actually something I did. I don't know if I can remember the question. Oh my God. I think I do. It was a simultaneous equation, if I'm not mistaken. We need to find it. I need to find that question. Hold on. It was a crazy simultaneous equation. It was insane. Hold on. Let me see if I can find it. I'll go look in here. Oh man, wait, what? Oh, that's graphically. No, none of that. No. Alright, no, that's quadratic equations. That's not what I'm looking for. Again, that. Okay, so they're trying to tell me about. Alright, when you can solve simultaneous equations using what do you call it? The matrices, right? You can do that. But I never that did I look for. Come on, man. Where is it? Alright, page 85. Let me see. Page 85. Oh God. Man, I don't even want to talk about that. I will lose sight of what I'm doing today. Right. Oh, yeah. You have commutative and associative, right? Yeah, I remember all of that. Let me see if I find that question. No, it's not this. It's not that. Oh, but these not so bad. And if for that, then I saw someone's weird. Hold on here. No. Yeah. Tell me what I'm looking for. Yeah, man. I know, you know. Oh, hold on. Hold on. All right, good. That was slightly unprofessional. I apologize, but you know, I could have easily just turned off the camera. I could have done it. All right. What? Hold on. Listen, man. This battery life thing that is going on. Listen, the charge is to 100%. Whenever did I use it, it reached 85. What was it doing? What was it doing? What was this doing that it reached at 85%? What was it doing? Because it wasn't on. When I say on, meaning it's not like I left the screen on like that. You see how bright it is? It's so bright that you can barely see what's going on. If I left it like this and it dropped to 85, that makes sense. But when it looked like this, and it dropped to 85, that don't make sense. That will not make sense to me. Anyhow, now me have to type in back the password. Look at me struggle to get back into my device. Alright, so I'm gonna get in. Let me see if I can find that particular question. More I find it. No, man. All of that. Those are the linear ones with the fractions. I never that. So where's the crazy one that I did see? There is a crazy one. something. It was a madness. Alright, I'm going to tell you what I remember from it. I remember getting something like this. Something like this. And something like this. I remember getting that. But just okay, so that we had that. I also remember, and I'm hoping that what I'm doing is correct. What was it again? Man, it might have been this, but I'm not confident that it was this. I don't remember off the top of my head. Don't remember. You see, this is what I get for not downloading the video. But if I had done that, then I would remember exactly what it was. But it was one of them ones where it was at like some decimal values first, and then we had to convert them, and then we had to reduce them and all of that. It was kind of crazy. It was kind of crazy. Actually, I believe this part was a minus. Right, it had to have been. I'll tell you why. Because when you happen to do this, if you were to do this and say 29x minus 3x, you'd get 26x. But that's just an example. But if you were to do this, 18y minus 2y, it becomes 18y plus 2y. That's what would have happened. Right? Just, again, for context. But I can't remember if this was the exact thing. I can't remember. Oh, man. And then I never used the tablet to take picture of the thing, so I don't even remember. No, it's not that. That was some computing screen. That is not simultaneous equation at all. Let me see. Now here what I'm going to do. I'm going to cheat the system now. I'm going to remove the light for a little bit. It's going to look crazy, so I apologize in advance. Let me remove the light. Let's search my phone. I have to look in my phone for this. I have to look in my phone. What's going on? Hold on. Hold on. Oh crap, hold on. This is what I just remember. I might not be logged in over here. So I have to be careful. What? Yeah, no. Yeah, let me apologize. Like I'm attempting to get to a profile and listen, man. Yeah, listen. You see this struggle life? We have to get out of it. Don't allow. What are you doing? Stop it. Fam, what do you mean by 99 plus? What does that mean? Nah. 50. Listen, man. I'm looking at my inbox and it's a disgrace. I'm apologizing to everybody in advance, alright? Let me apologize to you. Because I cannot believe this, actually. I can't. Why are there so many messages? What? Really? I'm going to use the Google login. Please, God. Please work. Wait there. Oh, not that. No. Not that. Not that. I need to. Let me scroll down. What? The struggle is so real. That is not what I asked you to log into. I didn't ask you to log into that. I swear, like, this thing is just annoying. I didn't ask you to log into that. No. I asked you to log into this. I scroll down. Sorry, I'm saying sorry. I have to apologize for this. Really? You know what I don't understand? Why do they feel the need to tell you something that you already know? So let me give you an example. They're like, hey, you just logged in with a new device. You know it's me, right? Like, I've seen people do skits on Google where you're in the house, you just step outside and you forgot something and you're ready for go back into your house and you're like, hey, who are you? And you're like, I was just here. I live here. Yeah, but I don't know who you are. I was just in the house a while ago. I stepped outside just to come back inside. Yeah, but I don't know you. Google. I will burn my own house down to the ground if you don't let me in. I will burn it down. Google, I will burn down my house. I'm willing to go homeless. You know, like that's the equivalent of you trying to get back into your account and then they're telling you, oh, by the way, did you know you logged in? Yeah, it's me. Yeah, that. Yeah, so again, I'm apologizing for taking away my flashlight. Oh my God, help. Why is everything, I swear to God, anytime you want to get something done, it's like the seconds take even longer. It takes forever to do anything. Yeah, okay. Okay. Not that neither. Definitely not that. Please God, let this be it. Mega press download on the button and pray that it lets me get it. Eh? What? Whatever, man. Oh, wait. Is this it? This is one of them, but I don't think this is it. Is it? Is this it? It's a June 11 live that You ever wanted to break your own phone? That's where I'm at today. I want to shatter this to the ground, but you know, this is what poverty does. Yeah, man, when you're broke, you can't afford for broke now. You can't afford that, sir. You can't do that. Right? Okay, so that's not the one. And I'm a little bit mad. No, I'm Alright? Father God, yes, I find it. Hold on. As a matter of fact, make a scream. Wait there. No, no. You can't do me this. I don't think you can do me this. I don't think so. Like, you really are going to do me that? Oh, Lord. No, this question was difficult. I'm wondering if it was this one. No, but there's one where it had like 2 decimal points. That's the thing. No, I don't think it was this one. No, yo, I really... Nah, man. It's always when you look for something you can't find it, you know. It's always when you look for something you can't find it. What? Ah, alright. Yep. Okay. We'll screenshot that. Oh, alright, good. Finally. Alright, we'll find it. Awesome. This never nice. Alright. So it was a simultaneous equation where I had 2.32x. Right. A plus here, a minus here. A 1.92y. A 1.44y. What is 15.6 and okay. Oh. So now I'm gonna have to move this over. Alright, good. Yeah, I believe this is the question. I believe so. Alright, so now, right, let's put that back where it belongs. There we go. Alright. Yeah. Now we can start the show. No. Yeah, okay. So there's a mistake that I made when I was doing this question originally. Right? There was. So I'll get to that. So now we can actually have the fun that we're supposed to have. So let me just draw a little line here. Obviously at some point in time I'm going to erase this. By the way, on YouTube, you know what, it's fine. I know what I'm going to do. I'm going to invert this video. Because what will happen is this. I think I have Clipchamp on the computer. So what I'll do is, even though you can't see it, that's fine. I'll probably describe it so that it makes more sense. Anyway, this is 2.32x, 1.44y, 15.6, 4.8x, 1.92y, and 2.88, right? Now, the trick to this is that all of these, if you really look at them, all of these are really fractions over 100, right? That's what it is. Hold on there. Place a button, hold on. Yeah. So, multiply all of this by 100, right? Multiply all of this and that by 100 and this by that and that by 100. Yeah. So, it's going to look like, you know what? Why am I doing that? Why? Watch this. You multiply this by 100. There you go. You multiply this by 100. There you go. Multiply this by 100. Put a 0 behind here. 1, 2. There you go. And then more importantly, well, this we have to be careful too. Because this is yeah? No. If you multiply this by 100, you jump 2 times, therefore, there you go. Multiply this by 100. There you go. Multiply that by 100. So now, that's what it looks like. Right? Now, me not deal with this. Those numbers they're too big. These numbers are way too big. Okay? Some of them too big. So, it means that we have to find the HCF of these numbers. So we have to find of this, this and this, this and this. So let's see what that looks like. Let's start with line 1, which is 232, 144, and 1560. Now, I apologize for the trucks in advance. Yeah. What does this look like? What can I divide this by? Obviously, I can divide it by 2. Alright, 2, 11 into that. So that's 116. Okay. So, you can start by saying 2 times 116. But 116, that sounds like 2 times 58. Alright, so we have that. So we have 2 times 2 times 58. But then 58 is 2 times 29. So we're going to say 2 times 29. Now this is perfect because prime. You can't break it down any further than that. Right? So we have that. Now, this is fairly easy. 12 times 12. Right? 12 times 12. So that is 2 by 2 by 3. And another 2 by 2 by 3. So we have that. So when you put them together, it looks like that. Now, we have 156 times 10 and 156. Well, look on this. We're going to rub out this 0 a little bit. If I add 12 to this, I get what? 156. Therefore, this number must be 12 times 13. So therefore, this is 12 times 13 times 10. Right? And that's, of course, if we put back the 0. Okay. So we could go into that now. The 12 is 2 by 2 by 3. The 13 don't need to change. What we can do is put the 13 on the end here. So you can put the 13 all the way over this one, right? So the 13 goes over there. Now we deal with the 12 by the 10. So let's put that together now. We have a 2 by 2 by 3 and a 2 by 5. So what we're going to write is, oh, you can't say that, sorry, let me write over here. 2 by 2 by 3 and a 2 by 5. So meaning this part, when you multiply them, is 12 and this part right here is 10. Again, I will give you the YouTube version of this video as well as this video and inverted. So I apologize if you're seeing it inverted, alright? So yeah, let me just apologize for that. So 2, 2, 3, 5. Alright. No! Anyway, don't follow me. It's 222, then 3, then 5, then right. Yeah, good. So now it looks like how it's supposed to look. Alright. So rub out this. And I'll rub this out here, right? So now, because you have the, what's the word I'm looking for? The prime numbers, the HCF easy to find. No, watch it. If I circle 3 of these, so I have 8 right there. Let me circle another 3 of these. Another 8 right there. And this, is another 8 right there. So we have successfully found the HCF. The HCF is 8, right? The HCF is 8. Yeah? So just putting that out there. The HCF is 8. So let's draw a line through this. That means that what is left? So this 232 was 232x. So let's put that x beside this. So we're going to replace this 232x. We'll go drop it to 29. So if we divide 232 by 8, we end up with 29. Alright, cool. If we divide 144 by 8, right, we end up with what? We end up with 2 by 3 by 3, 9 by 2. That's 18. So we're going to change that. So this used to be 232x. This used to be 144y. That's now 29x. This is now 18y. Right? So we're going to change this to 18y. Alright. Now, what about this? 15 times 13. 15 times 10. 15 times 10 is 150. 15 times 3 is 45. Add them together. So at least I had the first line right the first time. So if you divide 1560 by 8, you end up with 195. So we reduce this line A to its lowest terms. So now we're going to try that with 480, 192, and 288. Alright? Yeah. Alright, so let me robot this. Robot that, robot that, robot that, robot that, robot that, robot that. Rob that out. Okay. So now, try this again. Now we have 480x. And I'll write the x. 192y, 288. Oh yes. So watch this joke now. So let me see if I get this straight now. Something I noticed about this. This is 48 times 10. 48 times 10 is like 12 times 4. Alright, 4 is 2 by 2. 12 is 2 by 2 by 3. So the first part is 4. And then by 12 is 2 by 2 by 3. So that takes care of the 48. But what about the 10, which is 2 by 5? So therefore, I can just put this over here. There we go. Yeah? Just so we don't get mixed up. Alright, so this in fact should be 480 if we multiply all of that. Right? 30 times 2, that's 60. 60 times 8, yeah, 480. Alright, so now we have this. This looks like 64 times 3. But I'll write it over here just to see if we're correct. 64 times 3. Yep. 64 times 3. Now, 64 is the same as 2 to the power of 6. Right? 2 to the power of 6. That means we will write 1, 2, 3, 4, 5, 6. If you multiply all of that, that is 64. 4, 8, 16, 32, 64. But we multiplied that 64 by 3. Right? Now,
let me not forget the X here and the Y right here.
Oh, well, you can't see all of that, but let me just, can I, you know what, it's alright. I'm gonna go fix that. Ah, you see that? There you go. Perspective is everything, so even if you not see me, then yeah, at least you can see that part there. Good. Alright. This. What is this? I'll tell you. 144 plus 144. So therefore, if you know 144, you know 288. So you just put a 2 in front of 144. 144 was 2 by 2 by a 3 and a 2 by 2 by a 3. If this is 144, then put this a 2 in front of it, and there you go, 288. So now we need to, oh, okay, okay, let me see if we have a different color for this. I'll if I have green. Do I have green? Is my green here? Look, I'm looking for a green. But nice if I could find it. I don't know. Hold on. So I really can't find the green. Alright. Alright, whatever. Alright, anyway, so we're going to put something around 5 of the 2's. Something around 5 of the 2's. Again, something around 5 of the 2's. 2 to the 5 is 32, therefore the HCF of all of this is 32. Right? The HCF is in fact 32. Now, watch this. If it is indeed 32, it means that if we divide 480 by 32, we're left with 15x. If we divide 192 by 32, well, we're left with 6 and the y. If we divide 288 by 32, we're left with 9. And to prove it, let's multiply 32 by 9. 32 multiplied by 9, 2 9s 18. Yeah. Alright, so that governed. Right? What about 32 times 6? Does that work? Well, we'll see. 32 by 6. The 2 6 is 12. 18 plus 1. Got that? Yeah? So that worked. And then of course, what about 32 times 15? Well, 320 plus 160. And how did I know that? Because 32 times 10 is 320. Divide 10 by 2 to get 5. So you divide 320 by 2, you'll get 160. Because 32 times 5 is 160. Therefore, when you add them, You end up with 480.
Right? So we have reduced them to its lowest terms.
Yeah?
So we can divide each of these numbers by 32. Right? The HCF of each of these is 32. So therefore, we replace 480x with 15x. Oh, wait, lie. It's going for further than that too, actually. Now that I'm looking at it.
I know say something look wrong, you know.
It's deeper than 32. There's a 3 in each of these lines. Look for me too. Look for me too. Okay, let's so we'll go down one more level. This has a 3. This has a 3. And this also have a 3. So it's really not 32. It's actually
32 times 3 or what? 96?
it's probably 96. Let me do it. 32 times 3. Yep. And 96. It is in fact 96. So therefore, you're dividing this not by 32, by 96. The HCF is actually 96. So let me so because I knew that I reduced it to something further than this before. So when you reduce all this now, this is 5x, this is 2y, and this is just 3. So 5x here, just 2y. Yeah, so you end up with 5x here.
Why that's so dull? Don't know why that's so dull.
Why is that so dull? 5x here. 2y here. And if you divide this, alright, let's multiply 96 by 3. Yep. You still get
288.
so therefore, there we go.
Yeah. Holy power that.
So we finally reduce this to its lowest terms, right?
We needed to do all of that. Because the numbers we had before were kind of ridiculous. Don't make sense we do all of that.
I'm not going to work with 480, 192, and 288 when I know that they're all divided by the same thing. So at first I thought it was 32, but they have 3 in common. So it's really 96, not 32. Right? It can't be the HCF if it's not the highest possible value. 32 is smaller than 96. Therefore, the HCF of these 3, the HCF of these 3 have to be
the number 96.
yeah, just so remember that.
Alright, good. Now we can get rid of all of this.
Alright, we're done with the gymnastics of it. We're done with that. Done with that part. Done with that. So now we can start doing the other part of it.
Five and 29 are prime.
So we don't have to worry about how that will work out. You have the x side and the y side. So that means on this side, we multiply everything up here by the number 5. Right? So everything up here is multiplied by 5. Everything down here
multiplied by 29. Let me try and get this over there. Alright, yeah. Alright, good. 290 divided by 2.
Let me do that. 145. So the first thing over here is 145x. I'll just move it over a little bit. I'll just want a little space. Alright. Now I'm going to move this over a little bit. Let's divide 1950 by 2. Alright, 2 9s 18, 1 here, so 7. Alright, this is, alright, good. So 195 times 5 is 975. Alright, so we have that there. Multiply this by 5, 180 divided by 2, that's going to be, yeah. So that takes care of the first line. Now, multiply these by 29. 29 by 3, that is 87. Maybe because I've seen the number before. 29 times 2, well, that's 58. So let's do that. 29 times 5, well, that's the same as this right here. Right. So that's where it gets a little interesting. So now, these signs are the same, whether they're both plus or both of them minus. We're going to do what? We're going to subtract each line from each other. Now, it's a little different for what's going on the left. So, over here is what we do with x's. Over here is what we do with the y's. Alright? So, for the y's now, the LCM of 2 and 18 is the number 18. So, we multiply 2 by 3 by 3, which is 2 by 9. That gives you 18. So, therefore, this line up here not going to change. Multiply all of that by 1. I will multiply all of this down here by 9. So, 45x minus 18y equal 27 right there. And then this up here not going to change. So, we have 29x plus 18y equal 195. Now hopefully I can make you see all of that. Alright, good. Now the signs are the same, we subtract. When the signs are different, we are going to add. So, when you add these now, this look like 74x. plus, or rather, 18y minus 18y. That's a 0. Now we're going to add these two. Okay. Let me do this again now. 222. So that side is 74x equal 222. Alright, cool. We're done with that. Come back over here now. There's a mistake I made over here. And the mistake I made over here was this. 145 minus 145. Okay. After the 0. That go on. 90y minus 58, well, 90 plus 58 is 148y. Now I come over here and I say, well, I add them here. So now I'm going to go, this is 1062.
Now here's where the grave mistake comes in.
I only added here because when you have minus minus, minus times minus becomes a plus. But this is not a minus. So because of that, I cannot add this and that. I am subtracting this from this from this, and this from this.
So because I'm doing mental maths,
I'm never write it out. But never realize that you're saying 975 minus 87.
That's the mistake I made here.
So now, here we are. So 75 from both of them. I end up with 900 minus 12.
900 minus 12 is 888.
So I shall write 888.
So now when you put that in the calculator, now
divide this by 148 and this by 148, this by 74 and that by 74. If I multiply this by 3, let me see, 4 times 3, 2 carry 1, 7 times 3, 21 plus 1. Yeah,
x is equal to 3 over there.
And this, what would this be now? Well, you can add this to itself a couple times and see if you get this number. So I would argue that, let me see, 148 plus 148, that is what? 296. Add 296 to 296, that is what? That's 592. Add 592 to this, what you end up with? You end up with, let me not just do the mental maths. Oh, right. So if you multiply 148 by 5, you get 740. And if you add 740 to this, you end up with 888. So y is equal to 6.
Yeah.
So, yeah, divide this by 148, you get y. Divide this by 148, this will be 6. So 6 over here. And for this,
three over there.
Yeah. So, yeah, I made a mistake over here. The number that I ended up with was not 888, it was 1062.
And then I ended up getting something ridiculous. So that did not work.
So I'm just going back over
How you need to be careful whenever you're doing
something like that, because I minus here from here, alright, that's a 0. I minus this from that, but then I end up adding. And then I come over here and add again.
That's the mistake that I made.
That's the mistake I made. Over here is a little easier. This cancel already, so I'm just going to add this to that, add this to that. And that's done. Yeah.
There was another mistake I made.
But this was a little, what's the word now? It's like, okay,
Imagine this.
imagine you end up with you have two things. You have 55 x over 2, right? Or you have 55 over 2x
So, the real question is this. Is that really the same thing? Are both of those two the same thing? Yeah, the answer is no. Because look at what I never imagined. Imagine this. Imagine that up here is 55 over 2 times what? X over 1. Down here is 55 over 2 times 1 over x. Therefore, I made this mistake at one point as well. Yeah? So just imagine that. So the direction is important. If it is upstairs, it is x over 1. If it is downstairs, it is one over x. So yeah, since we all know pi, let's make this arc. Perspective is everything, and we're having a real chat about that. Because if we're not careful, we will make a big mistake with this and that. Yeah? So I thought that you could treat both of them the same. But this is 55 over 2 times 1 over x. So this and that cannot be, it will not work for both of them. It works for this, but not for this. So that's an important distinction to me. Very important distinction. So when you end up in a situation where you have this, and it is in fact equal to 5, what you can do is make your life easier. This goes here, that goes there. So your next line is going to look like 2x is equal to oh, really? It's gonna remind you of an Usher song. Come on, no? Really? Oh, I really thought this was going to, okay. And there we go. Why would you fail me? Why would you do that to me? Yeah, I literally had to try and do this. What them call it? You know that puzzle foolishness that they make you do? Yeah, I had to do that in the middle of the live. Let me apologize. So yes, this that's what that becomes. Right? Like a Usher song. Trading places, trading places. Right? So 2x goes where the 5 used to be, 5 goes where the 2x used to be. Right? You can actually do that. It's a shortcut for what really happened. What really happened? You multiplied both sides by 2x,
you end up with 2x times 5 equal 55. Then you divided both sides by 5. So 2x times 5 equal 55. Then 2x times 5 over 5 equal 55 over 5. Resulting in 2x equal to that. Yeah. There we go. This one is more straightforward, but that's a tricky one. So remember, where the x is, it actually matters. The x up here is x over 1. The x down here, 1 over x. Yeah.
Now, if anything else pops up in my head, or if there's anything else I need to go over, what did I do? There was something that I did with, alright, yes. I think I did something with the decimals and trying to prove, oh yeah, that's another thing. Okay, so I don't know. I don't know if let's just put it like this. I'm going to make this the last thing I talk about, and then that's it. I'm going to wrap up right after this, right? Now, perspective is everything. And what do I mean by that? Imagine this. Imagine you have let's say you have it is now your job to find out which of the two ones is actually larger, right? So the first thing I do is I say, well, how many times did I jump back? First thing I'm going to do. 1, 2, 3, 4. So this number I place over 4 zeros. Alright, cool. What about this one? I jump back 1, 2, 3 times. So this over here is that number without the decimal point, and it's divided by something that has 1, 2, 3 zeros. Now we're not quite done. See, what happens now is that, well, we have 1, 2, 3 zeros here, 1, 2, 3, 4. They need to have the same amount of zeros. The LCM of this and this is this number here. So let's put so let's see. If I cover 3 here and I cover 3 here, it means that I have 1 left to add. So I'll put a 0 here and a 0 here. Now, since we all know pi, let's make this arc, because what? Now we can focus on numerators. Let's focus on that a little bit now. How do I know which of these is bigger now? Okay, the 3 and the 3 is the same. 3 minus 3 is 0. 0 minus 0 is 0. But watch this. This here 4 is bigger than that there 0. And since the 100, 400 is more than 0, so if that is true, then guess what? It means that I, 30,480, I am greater than you, and that is why I am pointing at you. I am pointing at you to tell you that me, the big man, I am taller than you, I have more money than you, I have more views than you, I have more likes than you, I am greater than you. That is what that arrow indicates. Now, what if this was over here?
and that was over here.
What if they flipped?
If they were to flip, they were indeed to flip.
What would happen?
Well, you say the same thing. If I know I am greater than you, I will point
towards you. So it's always the larger pointing to the smaller. So you use your numerators to tell you which of the two fractions is actually larger. You use the numerator. Because when you have the same denominator, now you can compare them. And that's you see, it's only for things happen. You have the decimal places, you have place value, you have converting to fractions, you have LCM, it's only for things going on. Whole heap of things. So anyway, I have a couple more questions like this that I'll probably just bring up another time. But anyway, right now, you and me supposed to tired. So, you know what? This as I said, that's all. Yeah. So that's all. Alright, that's all. So again, thank you for, playing your integral part. And again, since we all know pi, let's make this arc, alright? It was a real chat. Yeah. So enjoy the rest of your day, people. Enjoy the rest of your day. Wait there. See? May I try to do this without, blocking the light. So let me. Well, too bad. However it go. Why is it? You know what? Me just have to pause the live and make it done.